Our planet Earth orbits a star. This star is the Sun. It sits at the very center of our solar system. Everything we know, every planet, moon, and asteroid in our cosmic neighborhood circles this enormous ball of hot gas. The Sun is truly immense. You could fit over 1 million Earths inside it. Its sheer size creates a powerful gravitational pull. This force is what keeps our planet locked in a steady, predictable orbit. Without the Sun's gravity, Earth would simply float off into the cold, dark emptiness of space. It is the anchor of our world, a constant presence in our sky that dictates the fundamental rhythm of our lives. The Sun is the source of almost all energy on Earth. It provides the light that allows us to see during the day. It also provides the warmth that makes our planet habitable. Without the Sun, Earth would be a frozen, lifeless rock. The energy travels from the Sun to us in the form of sunlight. This journey takes about 8 minutes to complete, crossing a distance of roughly 150 million kilometers. This constant stream of energy powers our weather systems, drives ocean currents, and provides the essential fuel for life itself. The Sun's influence extends far beyond just providing light and warmth. It is the engine that drives life on Earth through a remarkable process called photosynthesis. Plants, algae, and some bacteria use sunlight to convert carbon dioxide and water into glucose, which is their food. This process forms the base of nearly every food chain, but also releases the oxygen we need to breathe. Every meal we eat, and every breath we take, can be traced back to energy from the Sun. While it may seem constant, the Sun is not a static ball of fire. It undergoes a regular repeating pattern of change known as the solar cycle. This cycle lasts approximately 11 years on average. During this period, the Sun transitions from a state of relative calm to a peak of intense activity, and then back to calm again. This is not a new discovery. Astronomers have been observing this pattern for centuries. By carefully tracking features on the Sun's surface, they noticed that the number of dark spots, known as sunspots, would increase and decrease in a predictable rhythm. This was the first clue that our star has a heartbeat of its own. This 11-year cycle is driven by the Sun's complex and dynamic magnetic field. Because the Sun is a giant ball of plasma and not a solid body, it rotates at different speeds. The equator rotates faster than the poles. This differential rotation causes the Sun's magnetic field lines to become twisted and tangled over time. Think of it like a rubber band being twisted tighter and tighter. As these magnetic field lines get more tangled, they store up enormous amounts of energy. This stored energy eventually bursts through the Sun's surface, leading to the increased activity we see during the peak of the cycle. Every solar cycle begins and ends with a period known as solar minimum. This is the Sun's quiet phase. During this time, the surface of our star can appear almost blank, with very few, or sometimes even zero, sunspots visible for days or weeks on end. The Sun's magnetic field is at its simplest and weakest state, closely resembling a simple bar magnet with a clear north and south pole. For astronomers and solar physicists, solar minimum is a crucial time for study. It provides a baseline, a clear view of the Sun's fundamental structure, without the confusing clutter of numerous active regions. They look for the first signs of the new cycle stirring. The first sunspots of a new cycle typically appear at high latitudes, far from the equator, and have a reversed magnetic polarity compared to the spots of the previous cycle. Following the quiet of solar minimum, the Sun's activity gradually builds to a crescendo. This peak is known as solar maximum. It is the most exciting and dynamic phase of the 11-year cycle. During this period, which can last for several years, the Sun's surface is peppered with large, complex groups of sunspots. It's a time of magnetic chaos. The most visible sign of solar maximum is the abundance of sunspots. These are not just simple dark specks. They are vast regions of intense magnetic activity, often many times larger than the Earth. From these active regions, giant loops of plasma called solar prominences can extend hundreds of thousands of kilometers into space. Among the most spectacular events of solar maximum are solar flares. These are, hands down, the most powerful explosions in our solar system, sudden and intense bursts of radiation that release the energy equivalent of millions of hydrogen bombs exploding all at once. This colossal release of energy erupts across the entire electromagnetic spectrum, from radio waves all the way to X-rays and gamma rays. If a solar flare is the flash of a cannon, a coronal mass ejection, or CME, is the cannonball itself. These are truly colossal eruptions, where the sun expels billions of tons of plasma and embedded magnetic fields from its outer atmosphere, the corona. A CME is a vast, expanding cloud of magnetized gas that is hurled out into space, traveling at speeds that can range from a relatively slow few hundred kilometers per second to an astonishing several thousand. When a coronal mass ejection, or CME, hurtles towards our planet, it does not hit the surface directly. Thankfully, Earth has a built-in defense system, a powerful magnetic field that extends far out into space. The arrival of a CME is like a physical blow to the magnetosphere, a collision that triggers a series of dramatic effects. One of the most beautiful and awe-inspiring consequences of a geomagnetic storm is the aurora, known as the aurora borealis, or northern lights, in the northern hemisphere, and the aurora australis, or southern lights, in the southern hemisphere. This stunning display is a direct result of solar particles interacting with our atmosphere. The different colors of the aurora depend on which gas is being excited and at what altitude the collision occurs. The most common color is a brilliant green, which is produced by excited oxygen atoms. While the aurora provides a beautiful spectacle, the same geomagnetic storms that create them can be a nightmare for our technology-dependent society. The rapidly changing magnetic fields during a storm induce powerful electrical currents in long conductors on the ground. These geomagnetically induced currents, or GICs, can flow into our electrical power grids. This unwanted direct current electricity can overload and damage the giant transformers that are the backbone of the power network, leading to widespread and long-lasting blackouts. It is not just grids on the ground that are at risk. Our assets in space are on the front line. The thousands of satellites orbiting Earth are essential for modern life, providing everything from GPS navigation and communications to weather forecasting and financial transactions. During a geomagnetic storm, the atmosphere heats up and expands, increasing the drag on satellites in low Earth orbit. More seriously, the high-energy particles a storm brings can damage sensitive electronics, causing them to malfunction or fail completely. As we move forward in time, our attention is naturally drawn to the current solar cycle and the approaching solar maximum. The Sun is currently in solar cycle 25, which began in December of 2019. Initially, predictions suggested that this cycle would be relatively weak, similar in strength to the previous one. However, the Sun has proven to be a notoriously difficult entity to predict with perfect accuracy, and it often has surprises in store for us. Understanding the solar cycle is more than just an academic exercise in astronomy. It has become a crucial aspect of modern life and a key to securing our future. Our global society is now more interconnected and more dependent on technology than at any point in history. Beyond protecting our current infrastructure, understanding the Sun is essential for our future ambitions in space. As we plan for a sustained human presence on the Moon and crewed missions to Mars, we must be able to protect our astronauts from the dangers of solar radiation. In the end, the Sun's wild moments serve as a powerful reminder of our place in the cosmos. They teach us that we live in a dynamic and interconnected system, where events happening 150 million kilometers away can have a direct and profound impact on our lives. By continuing to study our star, we not only protect ourselves from its occasional fury, but also deepen our appreciation for the delicate balance that makes life on Earth possible. Watching the Sun is about safeguarding our technology, enabling our future, and ultimately, understanding the magnificent and powerful star that gives us everything.